Hello, welcome to this problem. So this problem will be about MC question, about division algorithm, about remainder theorem, and also about the factor theorem. So first of all, so Px is a polynomial, and then for the first two conditions, just the remainder when divided by x plus 1, and then we know that the Px is divisible by x minus 1, and then we want to find the remainder when Px is divided by x squared minus 1, which is not a linear polynomial. X squared minus 1 is not a linear polynomial. So that's why so the required remainder cannot be found using, or the required remainder cannot be directly found using remainder theorem nor vector theorem. And then the required remainder is also cannot be directly found because the corresponding quotients is not given, and then the Px is not given. So that's why this problem actually is not that direct. So that's why here we may need to let Px because the quotient is not given, so that's why Qx and then times x squared minus 1, and then the corresponding remainder polynomial will be given by ax plus b. So ax plus b is a linear polynomial because x squared minus 1 is quadratic. So that's why the required remainder so the degree will be at most 1, at most 1. And then we try to use p negative 1. So why we try to consider p negative 1? Because here when Px is divided by x plus 1, the corresponding remainder is negative 2. So by remainder theorem, so p negative 1 will be negative 2. And then you can see since this one is 0, this one is 0. So that's why here the whole term will be 0. And then we can successfully set up an equation involving a and b. So using a similar trick, we try to consider p1. So why not other functional values? Because Px is divisible by x minus 1. So that's why by factor theorem, p1 equals 0. And then again, the underlying term is 0. So that's why without knowing Qx, without knowing the quotient polynomial for each divisors or what, so we can still set up two equations involving a and b only. So and then maybe just equation 1 plus equation 2. So 2a will be 2. A equals 1. And then put a equals 1 back to equation 1. So that's why 1 minus b equals 2. So that's why b will be negative 1. So that's why if you plug all these things back to the corresponding the first step, so that's why the remainder will be about this thing. So with a equals 1 and b equals negative 1, so that's why the correct option would be option B. And then the problem is done. Thank you for watching.